All right, take your seats, please. Do not panic. Do not panic. This is just a drill. All right, come on, Robert. Move your behind. Okay, well, Walter and I are going to take any and all questions you may have. The live stream is being watched hawkishly by Ali. Thank you. We have Eric is running the microphone, and also Amaury graciously agreed to run on the other side. So we're ready for everything you've got. Okay, we're done. Steve. Steve.
What happened to the solution for R-value references?
Walter is to answer.
I'm not really sure. Well, we do support, overloading based on if it's an L value or an R value, and that's pretty much where it stands.
So just to give more background to people who have not keep the score at home, it's all about functions that accept parameters by reference, which are quintessentially L values. And a very common practice in C++ is to do that for efficiency reasons alone. So it's just a cheap way to pass a value through. And in C++, they ensure there's some level of correctness insurance by means of const. So essentially, if you have an R value, you convert it to a reference to a constant object, and it does go through automatically. It's one of the most it's the most trivial. It's a trivial conversion. So essentially, it's going to be the compiler is going to be really eager to gobble it up and do the conversion, which subsequently has caused problems for defining R value references. And wow, the level of apostasy. So I've I've been like a C++ guy, and I can't believe I remember all of that for a long time. So essentially in C++, it's been a workable solution for many years. And naturally, people come into D, they ask the same question. Well, what's the deal with, you have an R value, you want to convert it to a reference to a constant object, and why doesn't the conversion go automatically through? And one problem we identified was, you tell me, was of those people who do keep score at home, one of the problems with accepting that was, and is in C++ actually, is the fact that you can pass an argument by reference into a function, it returns back the argument by reference from the function, or actually a subset, part of the argument. If it's a struct, you could return a field of it by reference. So essentially, reference goes in, reference comes out. The function is opaque for all type checking purposes, so you don't know the body of it. And the net result is that at the end of the day, you end up with reference to an object that just doesn't exist anymore, because our value is going to have been destroyed at the end of the expression. And that's actually it's an ongoing problem in C++. And they said, you know what, deal with it. Sunglasses, deal with it, right? And we want to do better than that. And last year, we had a solution based on a combination of compile time and runtime verification, which I think is workable. It's simply the case that it hasn't gotten to, it's been on people's radar, but it hasn't gotten to the front burner until now, when it's going to get back on the front burner, and then subsequently, after the conference, it's going to go back on the, right? So my opinion is that using this trick for making more efficient conversions may be not essential for the success of D. D objects are not arbitrarily expensive to construct. The inconvenience is for the most part minor. And essentially, the way I see it is if it were essential, there would be a lot more clamoring about it. That said, I would like to do something that's principled and good. So as long as somebody has such a good principled solution in mind, it would be great to look into implementing it. Oh, that was only one question. We have like 6. Chuck.
I have a meta question, a question about the question. So I'm just curious why we want R-value references. In C++, they're used for move semantics. Is that what we're talking about, that kind of efficiency?
It's more about the efficiency of passing a temporary object into a function. That's pretty much it.
Okay.
Like people use const reference in C++. Like many times, they're not interested in the constants of the object or sort of the philosophical aspect of constants. They're interested in having a function accept easily either L values or R values transparently. So it's sort of the, right.
Okay. Well,
that's a good meta answer.
That's a better reason.
Okay.
I'm sitting here looking at Bartosz Maluski's article, Who Ordered R-Value References? You know, and I don't know if you've read that. It's a 3-part thing that was written 5 years ago, but he just talks about why we don't need it in D, but this actually sounds like a reasonable use case. So.
Right. So that's sort of a slightly different case, because that's the case so you want to avoid most of the arbitrary cost of copying in C++, which indeed you don't need in D. Right. The only reason you would need to bind our values to references in D would be, well, I want to just copy a pointer instead of copying a structure, and I think that's a legitimate reason. Okay. It's not essential, it is legitimate, though, nevertheless. Ali? You got it. You're good.
Oh, great. So, Andrei, what's your stance on manifest over enum for manifest constants?
Okay, so this was the online question, right? Background. So years ago, many years ago, how many years ago? Like enum, use enum for manifest constants. There's a talk about introducing a keyword manifest instead of just simply reusing enum for manifest constants. And Walter and I decided to not define a new keyword and go with what we had for a variety of reasons, one of which being the extant semantics of enum at that point were like 99% of what we needed. So we went 1 more %. Adding a new constant seems like not a proportional response. If you have anything to add?
Yeah, pretty much. It's just save the keyword pollution. There just didn't seem to be any point to having another keyword when the enum keyword would fill the role rather nicely. And we understood that it's a little kind of a moment when people first run into it, but once you've used it for a while, it just seems perfectly natural, and I don't really see any real issue with it.
I think time is, the passage of time on this matter without people protesting it. I think it's enough proof that things are business as usual.
We've had some other syntaxes that people have thought were odd at first, and over time has proven to be actually a very, very good decision. And once people get used to it, the issues go away, like the bang syntax for template arguments.
And losers too. Strings for lambdas, anyone?
Yeah, Timothy. That one went under the bus. Yeah.
I have a question regarding mangling of templates. Right now, actually, I don't know if everybody realizes, but it's exponential in the template depth nesting. And that has to do with the fact that for eponymous templates, you're repeating the template name twice. And so as you nest, you're actually growing exponential instead of linear. So I'm wondering whether we can have a special mangling scheme for eponymous templates.
The only purpose of the mangling is so that functions and names with the same name but different types will not collide with each other as far as the linker goes, because the linker doesn't know anything about types. So there are various ways to try to reduce the size of the mangle name. And one technique that is not really explored but could work is, instead of trying to come up with clever schemes where I can reuse this name here or something like that, just use LZW compression on it. And that will eliminate duplicates. So somebody wants to do a pull request to do LZW compression on the names. And the nice thing about LZW, it's reversible too, so the demangling works. And so you won't really be able to visually or manually decode it, but with the tools like the demangler, they should be able to demangle it just fine. And I think that would solve not only that problem, but in general would greatly reduce the length of the mangled names.
That's interesting because LZW would deal with the exponential, like repeated symbols. It does that very well.
But I still think it's possible to have like a special. Anyway, this can take it offline.
Okay.
All right, Brian.
So, if we have a de-improvement proposal and it proposes a change to the parser, should we ever accept that without a corresponding change to the grammar specification?
I see that as a more general question, is changes to the language without a language specification pull request. We shouldn't. They really, should be both be done at the same time. There's a bit of a mechanical problem in that the specification and the compiler are in different repositories, so they're not directly linked to each other. I don't know how to make that happen, but it would be nice. But yeah, any changes to the grammar or even to the language should be accompanied by a pull request for specification change.
Well, one question would be, how often does that happen? Like, how often do the changes happen?
Well, the eponymous template syntax introduced a few bonus features when it was implemented.
Right. But essentially, if we're looking at something that occurs like every few months, maybe managing by hand is a good thing. But if it happens a lot more often, I'm a fan of automation. We should put one of our famous lieutenants on automating either the generation of the at least the grammar, because semantics is difficult, but generating the grammar from the compiler, or vice versa, or at least verifying mechanically that the two are in sync. This is not quite a pipe dream. I think at least for the simpler lexical stages, it could be done.
Yeah, we have been pretty successful at raising the bar and not accepting pull requests that don't come with tests. But we've not been quite thorough in language changes that aren't accompanied with a specification PR. So we need to do better on that.
We have a high bar on accepting pull requests in general, I would add. Allusion to my talk this morning. Yes, Ali.
Is there any plan to reduce the number of attributes? This comes from the live stream. Pure, no throw, shared, safe, no GC, etc. Or are we happy with those?
We're not happy with them. There are a lot. We can't seem to figure out a way to reduce the number. However, templates don't need attributes. Because the source code exists for the template, it has to, or it can instantiate the template. The compiler can infer attributes from it. So what, and I've talked about this with Andrei for a while, what we'd really like to do is push the language's ability or the compiler's ability to infer attributes rather than having to go in and stick them in yourself. So then, because like a lot of constructors are really they're just obviously pure. All they do is do a couple of assignments and nothing else. So, but it's really kind of annoying to have to go in and say, yes, this is pure, yes, this is pure, yes, this is pure, when it's obviously pure. So we kind of want to work towards having the compiler automatically see that, yeah, this is pure. Now, there are some issues with doing that and separate compilation, and we have to find a way to deal with that. So that's the direction I'd like to go with that. And the neat thing about going in that direction is it doesn't break anything. It just makes things work better.
Right. To summarize, I think we like Essentially all of these attributes are informational bits about functions, and that's very good for type checking. It's valuable and essentially can't be done otherwise. You gotta have good summaries on functions. That said, two things: we like attributes. We don't like having people type them out. Type them, right? We don't want people to sit there and write the attributes. Like, oh, like the classic Java joke, pure, not pure, like static void main, whatever, public static, I forgot. But it's like the hello world has like 5 things in a row that are, all of them are keywords and are unnecessary in concept. One comment about this, Walter alluded to it, from our lucubrations on this matter, it came forward that constructors are special. And this is no surprise. They've been special in C++ in some ways, and they turn out to be special in D in other ways. Notably, if you have, constructors should be sort of like templates. They should have bodies there, present white box. And the moment they're present, there's a lot of deduction that can be done on constructor that influences the entire object's behavior. So one possible direction would be to sort of formalize the fact that constructors are special and say, constructors must have body. They can't be defined out of line, and they behave in many sense like white box templates. Yes?
Hi, my name is Yuri, and I'd like to ask if we can finally remove the monitors from the object class.
Did you actually write that pull request?
Yeah.
Okay, awesome. Have it.
I think it's a great idea.
Could you kind of state the problem for?
Okay, the problem is classes have 2 implicit members in them. One is a pointer to the V table, the virtual table, and the other one is a slot for the monitor. But it turns out that that slot for the monitor is hardly ever used, because how many times do you use a synchronized class? It's pretty much almost never. So the URH came up with a proposal for how to get rid of that. And in the rare case when object actually needs a monitor, it uses a hash table to go find the associated monitor to do it. Is what I'm saying correct?
Yeah, that's right. Also,
Right.
you can define a class with an attribute like monitor, and then it will be inlined inside it.
Yep.
Mm-hmm. So it looks pretty good, like this proposal will not break any existing code that uses it, which is a huge plus. And the downside is there's a little runtime performance cost for classes that are synchronized. So is that a reasonable trade-off to make? I think it probably is. I guess I'd like to hear from people who are actually using synchronized objects if this is a reasonable trade-off.
Who is? I only see thumbs. I don't see middle fingers. Okay. There's 2 addenda I would make to this. One is, interestingly, synchronized has been like a real pain to formalize. Like, what's the interaction between synchronized and shared? How does it affect shared things? How can people effectively use synchronized in classes Java style and just have it work and type check automatically? And the type checker should kind of figure out interesting things, such as there are no races in this program, which is big. And so I would like to see it gone, because it's always been tenuous to synchronized with shared, right? And the second aspect is, it is my experience that any solution that relies on a global hash table is not going to scale. So, it sounds a bit awkward to me to rely on that. But I'd be glad, since you added the whole attribute thing. I think it was a subsequent, amend of the thing.
Yeah, one reason for monitor to leave still is the finalization callbacks, which are for signals. They are used for signals, okay? So I couldn't factor that out, and it probably will need some more thinking.
Okay. So the idea that we have a hash table in there that's global and tenuously scalable, let me say, but that you can bring back the performance with by actually plastering at, synchronized or whatnot, an attribute on the type. It does seem like a workable solution. My opinion is I'd be happy to see it gone. At the same time, let's not forget we're not representing the many users, like people in this room who can't take a vote right now and say, oh, let's have it go.
Yeah, there's always the problem of the silent majority, the users who heavily use D, who don't post on the news group, we don't know who they are, and then we go and break their code. That just makes them very, very unhappy when we do that.
So let's say cautiously favorable. So thanks for the work. It makes all the difference that we've actually done the work as opposed to just asking the question in a void. Essentially it's just we push a button and we've done it. I think we should do it personally. So let's keep the discussion going. Yes.
One more question. Does D have any promotion strategy behind it? Because current new languages like Go and Rust and etc., they have pretty much more aggressive than D marketing. Yeah. They have cool websites and all the whistles and So is D sponsored in some way? How many people are working on D full time?
I'm on one. So so there's a difference. There's people working in D versus on D, right? And the size of one crowd influences the other. Clearly, corporate sponsorship is good for a programming language, as we've seen with a lot of languages. I believe we are right now in the stage where we are being noticed. Like 2 years ago, there were a lot of people I'm working on this language called D. It's like, oh, are you kidding? What D? What is like C++, and it's like D. Oh, what a joke. And they didn't know there exists a language called such. We've gone past that stage for the most part. And I think we're ready to say, well, it's a production-ready language. There's very good proof to that in a variety of corporate and academic settings. And it's time to kind of expand into the next level, which would include corporate adoption and corporate sponsorship. At this point, I'm doing my best within the confines of my employer's work, and I suggest that everybody here does the same. This is the one path that's going to lead to success. It's just doing great work and promoting it. Other than that, right now, for example, we don't have. I'm the website guy, and I'm like a horrible HTML guy, as I'm sure you've seen, right? But definitely we need to ramp that up. And if we ramp things up properly, corporate adoption, I have no doubt is going to follow.
One thing that helps enormously for getting the word out on D is when there's like a Reddit article or a Hacker News article or a Slashdot article about D to, chime in with your comments. Good or bad or insightful or educational or informative, just kind of be there. That helps a whole lot to show people that there is a community and it's very active and involved, and it really helps to have that presence out there. And you can't buy that presence. That presence comes from, people like you guys just being enthusiastic and just kind of being there.
Ali, for the internet?
Yes, there is more from the live stream. I think there's a dip for static for each from Timon. I'm going to combine more questions. How about static if version and debug inside inline assembler blocks? And will scope ever be implemented properly?
Very good questions. There is a pull request to put static if in inline assembler. It's currently sitting there waiting for me to review it.
Not you. Not you. You and others.
Okay. So there's that. Static for each had some fundamental problems with it. It's been proposed many times, and it has serious problems with it that remain searching for a good solution. What was the third item?
Scope.
Scope.
Scope
if you're
variables.
using
Yeah.
a lot of inline assembler where you need a version or debug statement inside it, you're probably overusing the inline assembler. I've used version and stuff like that with inline assembler, but I kind of put it outside. I find putting it inside, even though D doesn't allow it, if I put it inside, it makes it nearly unreadable to do that. Putting it outside, it seems more manageable and easier to reason about. So I'm not too thrilled about that idea.
Scope variables?
Oh, scope variables, yes. The nice thing about scope variables is, let's say you have a ref counted object and you want to pass it to a function. When you pass it to a function, you're making a copy of that ref counted variable, or a copy of the reference, and that means you have to increment the reference count. And when you leave the function, you have to decrement the reference count. And when you decrement the reference count, if that function threw an exception, you have to put the decrement inside of an exception handler. So it winds up being a very expensive operation to do that. And one way to mitigate that is if you know that that reference cannot escape the function, then you don't have to increment or decrement the reference count, and it's just passed like a regular pointer. So the idea with the scope is to guarantee or to tell the compiler that I don't have to deal with a reference count on this one. So when we get a reference counting solution better underway, that's going to become fairly important to do right. Another thing I'm looking into is, although we have this, it's not fully fleshed out, is the pass-by reference, not making sure that it's not allowed to escape. So in that case, when you're passing a ref counted thing by a reference, it doesn't have to, deal with the reference count. So then you run into the thing, why have both scope and ref, which is currently an unresolved problem. So we are thinking about that. There is ongoing work with that, and I really want to push that forward.
Jonathan?
So I've got 3 things I'd love for you guys to mention on. One question from work, the guys at work. They said, so what about tuple unpacking syntax, since the comma separators comma operators being deprecated? The backtraces that I mentioned in my talk, and that amazing mangled symbol, and any comments on how that could be or demangled?
Those are 2. Where's the third?
Well, the backtrace is
It's just as hard. It's so hard it counts as 2. Okay.
Yeah.
Well, tuple unpacking, we gotta have some way of tuple deconstruction. Library tuples work great until you hit your own, that happens. Let me clarify. You have a tuple, we have a struct tuple that accommodates as many types and values as you need. But when you try to say, well, let me bind this integer and this double and the string to this tuple, you're gonna have to awkwardly write 3 lines of code instead of just 1 like in Python. And we gotta have some. Kenji actually worked like 2 years ago. He had a full-fledged pull request on the thing, and we kind of stalled on it. We thought, well, let's make sure this is all we need, because otherwise, if you have like a patch design, we don't want to patch it again later, and so on. So it seems to look, after Kenji's back then failed pull requests, time has passed, and it looks like this is really the only thing we need with tuples to make them palatable. So it's going to happen. One way or another, it's bound to happen. It's not going to happen. The second, we at Facebook also experienced the same issue. We have stack traces, and it's like, oh, this hex address, I think I know what function in the, that, right? It doesn't work. It can't. So we're looking into it. We have our own demangler, our own address to line facility. We're trying to plug into that. So essentially, we got to look into it. We got to fix it. I think this is in a way easier because it's a runtime library issue. It's not a core language issue like the tuples thing. And that was it, right?
That amazing symbol that I had at the end of my talk for demangling it, that you pass that to the demangler and it just kind of passes it back and says, I give up.
That's a bug in the demangler, and you just volunteered to fix it. Everybody took a step behind, which kind of left Jonathan hanging. Ali?
Actually, I already reported that bug a while ago, and Walter said that it was not worth fixing it because it was not that common to have that long Mongol name.
Well, what's not common becomes common. It's a common pattern. Ali?
Again, from the live stream, why is there a bias against finalizers and destructors in the D community when there is no performance implication?
Who's biased? Raise your hand. Who's a racist here? Right. You want to answer that?
I don't really understand the question.
I guess we don't have finalizers and destructors. Why?
We have destructors. They're the same thing.
Okay.
I think that the question harkens back to the discussion on the main forum a month ago, when Walter and I were like, you know what, the whole semantics of destruction clauses during garbage collection is kind of weird, and we're considering throwing it all together. And there's been quite a bit of pushback from the community, and we decided to keep that feature, however tenuous is to use in the language. I think at this point we're going to keep class destructors, and they're going to be run during garbage collection. We're looking into better ways of limiting what class destructors can do to reasonable things. Probably all they could and should do is things like close files and assign pointers and things like that. See you tomorrow, Chuck. And he said he's going to leave early. He's not bored of this, okay? He asked for permission. And so, I don't think there's a bias as much as objectively admitting that there is a problem with these particular things. It has always existed in other languages such as Java. It's a known issue. It doesn't have an easy solution. So that said, we're looking at it, and we're looking really hard, and we stare at it really really real bad. And we hope we're gonna find a creative solution to this that's gonna please our users. DiceBot. You should know this is DiceBot, by the way.
Hello, everyone. So, one of big issues with metaprogramming, something that I have been complaining about for years, is the issue of symbol and code bloat that comes from active usage of metaprogramming techniques. What is your current stance on fighting it and trying to eliminate it? I guess it's a question to Walter.
Okay, I guess I thought about that a lot. Template instantiation and I presume mix-ins lead to a lot of code expansion. So consider like a template that adds 2 ints and returns the result. It's a different function from a function that adds 2 uints and returns a uint. But it turns out that the generated code is exactly the same. But to the compiler, there are different functions. To the linker, there are different functions, and you wind up with 2 functions in your binary. And I've often thought a pass in the compiler that would take any 2 functions and decide if their generated code would be the same, I can combine them, would get rid of a large chunk of template bloat, because a lot of types are they're different, but they're kind of gratuitously different. They're different because maybe I want to have some better type checking, like, this string is a verified string and that other string is not a verified string. So I want to keep the types distinct in the compiler so I don't mix up verified and unverified data, but to the code generator, there is no difference between them.
Also, like a lot of qualifier use generates the same binary, like const immutable or mutable, and it ends up just generating the same code.
So, and that's something I've thought about for a long time as a pass that works a lot like the inliner, but what it will do is compare two functions, expression and statement by statement, and checking to see that semantically they're the same. For example, for add of two integer types, as long as they're the same size, even if they're different types, it's going to generate the same code. But for divide, which generates different code based on whether it's assigned or an unsigned, they would generate different code. So although the add could be coalesced, the divide could not be. And I think that, I've often thought about implementing that.
I actually had made somewhat different problem about like keeping unused symbols and stuff. For example, like just creating a small D snippet, which just uses this algorithm map over an array, creates, as far as I remember, over 500 symbols. Most of those actually get inlined, but still remain in the resulting binary. So, kind of, what's your opinion about fighting exactly this issue?
Okay, that's the old unused symbols should be removed by the linker problem.
Which is still not solved, actually.
The problem was when we turned on the LD feature, which is removed unreferenced symbols, the D programs all crashed. So the linker appears to be inadequate. And part of the reason it appears to be inadequate is some of these functions, the only reason they exist is so that they can put in tables like the unit test tables or the static constructor tables, and the linker didn't regard them as existing then and would just delete them all. So
I think
I don't want to get into writing another linker.
I think the module table, like probably we could ruin Attila's day because you can't enumerate everything in a module unless it's used or something like that. But essentially, like I remember you're talking about doing work on that, such as getting rid of everything unused, essentially instantiating module info lazily and that kind of stuff, and the whole module constructor making it lazier and easier to kind of track.
Yeah, I did a change recently, which is to not instantiate templates that are instantiated presumably by something else. And then the other thing I was thinking about was when you import something, the compiler goes ahead and eagerly compiles it, changing that to full lazy. So when you import things, the compiler only compiles just enough to figure out what the declarations are in it, and then only compiles those declarations if they're actually referenced by a module that's on the command line. So I see you eyes rolling around.
But it's in a good way. It
looks like a good way, a thoughtful roll.
Clockwise. I think it's Robert and then Ali.
So what are the plan?
Oh, sorry, Martin.
I wanted to amend something on that topic. Like the first thing is like the Microsoft linker can nowadays do something called identical condat folding or something, which does exactly like the example you named. If you have a template which adds uints and another template which adds ints but generates the same code, then they can detect that in the linker stage and fold them out and use the same function.
I think GNU has the GNU linker has a similar feature.
Maybe.
I think it's a rather blunt instrument. It would behoove us to kind of detect that and kind of save a lot of work earlier on. Because right now we're generating, for example, we're generating a lot of code that we needn't to, right? So.
And the other thing that I see quite often to avoid code bloat from template instantiation is like factoring out common things, because like the variation between different templates with different types is quite small. You can factor out common things and use a smaller number of arguments on that.
So you're saying it's a programming technique that people should be using?
It's a programming technique. You can put that on a module scope, and then it's not within the template, and you can reuse it for more types because you don't have a full combinatorial explosion of 5 template arguments and different combinations. Sometimes it's possible to factor out things with only one thing.
But are you saying this as an education issue, like we should tell people to do that, or automatically kind of?
I wouldn't know how to do that automatically.
Okay, so just essentially like.
But it helps sometimes.
All right, you write a web page on that, Lieutenant. Okay, Robert.
So what are the plans on the allocators, and how may that lead into containers?
Yeah, I had a couple of slides on those, and then I thought I'm giving myself too much importance, and I removed them for my talk this morning. Allocators, they're going to happen. They're in good shape. I'm not sure if you remember, like DConf 2013, I talked a bit about allocators. Here's what I have in mind, and I put like a picture of a beautiful airplane there, and this is how I think the design should be. This is what I think it should look like, and I had no idea what I was talking about. And today, today I have a much better idea on what I'm talking about. Allocators, so there's a std allocator. I guess if you Google for it, it's just going to find it. It's been discussed already a bit. We've been successful at separating the typed part from the untyped part, and we have a very good framework for the untyped part, like that deals only with allocation of bytes and alignment and all that jazz. And I have tests, I have benchmarks, and it's doing pretty good. I'm very enthusiastic about the way that turned out. Then we need the typed part, which is going to be actually easier in many ways, but it's work in progress. I believe that at the end of the day, we're going to have a very good allocator library for D. There's a gentleman who took the task of actually porting it to C++, and he's already experiencing good results. He's also very enthusiastic about the port. So that's a good proof that the design kind of holds water, stays together. So, you know, the news is good. Allocators are going to happen. They're going to be good. They're going to be like very, very flexible. But they're going to be more like a Lego toolkit that people can use to build their own allocators more than just one allocator that does pretty good overall. That said, we're going to have a number of type definitions for good allocators that are prepackaged. The allocator I plan to include with tracing. So people who want to essentially enjoy automatic memory management could opt in to that. And I plan to design an API for people to say, I want to install this particular allocator. So whenever people type new or type array concatenation, they're going to call into this particular allocator. And then there's going to be a stack of allocators. They're going to install and uninstall allocators and so on. So things are happening, and it took me a year, but I think right now things are shaped up. It looks good. So stay tuned. I think we're kind of running out of time here. I mean, we're minus 16 minutes already. So 1,
Attila has a question.
2, Ali, yes. 3, Dragos, 4, 5. Oh goodness. Okay. Who's with yes, no questions? Yes, no questions.
No.
Nobody has a yes, no question. What was I thinking? Okay, quick, come on. 10 minutes. Yes,
no
Ali,
question.
yes, no.
Multiple return values can be supported by tuples, returning compiler tuples from functions. Yes or no? I mean, will that happen or not?
You mean having a compiler return or functions return a tuple instead of a single value? I'd like to do that. It's been talked about a lot. It just hasn't been done.
I wouldn't. So here we kind of disagree. I think we should have library tuples and unpacking, and we're good. Attila.
So this is a minor quibble. I'm going to ask if we're ever going to get copy constructors, and the reason why is because right now we can't copy from const, because a copy is move plus post-split, and I can't move from const, so
yeah,
it doesn't make much sense to me. But I understand why, but
we got to fix that. So it's something we need to look at it. It's a dark, unpleasant corner of the language. Kenji has a very complicated proposal for the language, which I was like, it's too complicated to live. It can't. We got to look at something simple and robust there. So it's on the radar.
Okay.
Third.
Was there any improvement to the GC since the 2 talks of last year? Any improvement to the GC since last year 2 talks about precise and concurrent garbage collector?
There's a lot of activity. You know, I'm gonna be like Karl Marx here. I'm gonna say there's a lot of accumulated improvements that are not visible yet, but they're gonna become visible soon. There's gonna be a qualitative jump following the quantitative accumulation. Robert, do you have anything to add? Okay, not yet. So, you know, there's work on it. There's a lot of work on it. Allocators are going to plug into that too. So there's stuff happening. I have absolutely no doubt it's going to lead to fruition. So when, that is the question. Dragos.
So the question is if there are some thoughts about formalizing, you know, a process for deprecating things. Yeah, I work for a company where we have a couple of tens of thousands of code in production, and I think it's a good idea, you know, for each new version of the compiler to have a list, what works, what is new, what is. We have the release notes, but I think there is a big barrier to, you know, to make breaking changes, and there is always these discussions on the forum that we don't want to do this because it breaks the compatibility. But I think if we formalize this process, it could be done, and I think it's realistic to have something like this because the things are changing.
We still do break things now and then when we really have to, and the idea is. First, we decide to do it and get pretty much consensus, and so nobody's going, "You're going to destroy my company if you if you change this." And then we go to making use of it a warning and let that, you know, percolate for a year or so, so that nobody's going to. It's not going to hit anybody by surprise, and then it gets upgraded to being deprecated, and that maybe lasts for a year or something like that. So that a person has to take active measures to keep that code compiling by throwing the allow deprecated features thing and then remove it. But that gives people plenty of time to come and tell us that we cannot take this feature out. So we've been trying to follow that process.
I think you're alluding to something more sort of like you're on a formalization, right? More than what Walter described, it would be more like a procedure, a step-by-step process. But I think you're thinking of something like a diff for language changes, or a kind of a Git for language changes. And I think this is a research topic in of its own. It would be terrific because, for example, before Git, a lot of you are like, I don't know how to do forking, right? It's too difficult. And how to merge things, and it was like a nightmare in SVN and predecessors. And with Git, Git came about, and it was like kind of solved the problem. And I kind of have one lonely neuron in my mind thinking that there could be the case that there is such a thing as diff for language changes, and there is such a thing as forking for language changes, and there's such a thing as merging for language changes. So there's such a thing as formalizing the process of making semantic changes to a language. I think it's a research topic. I think it would be very interesting if one of our famous lieutenants would sort of warm up to that problem and think of it a bit. My lonely neuron is insufficient to kind of think of that particular matter beyond the intuition that it's a very fertile topic to think about. Carl, this is really the last question. Carl Eric.
Should D try to compete with Rust on safe regions?
Yes. And it shouldn't compete. It should destroy Rust. Okay? It's my opinion that Rust has made a strategic mistake for a tactical victory. I think it has invested very much in this particular topic. And I think this is a mistake in language design. It can't afford to invest too much in one particular aspect at the cost of the overall game. That said, it's a topic that's on many people's minds. And it's the first sentence when everybody discusses Rust is like, oh, it has these nice regions going for it. I don't think regions are everything and all be all of a good programming language. And I don't even think they're like the most important part. They are nevertheless one important part. And Walter has worked on inference of uniqueness that actually works out of the box without people typing anything. And I think we should kind of start from that work and add to it and make it really compelling.
I think one of the neat things about the new attribute inference is it's in the compiler now and nobody's noticed it, which means it's working. Because to me, that's the best kind of features is code that didn't work before now works. For example, it enables you to construct immutable objects without casting, because it can determine if an expression produces a unique result, and if it does, that can be implicitly cast safely without any, using the blunt instrument you had to use before. So I think we can push that pretty far, and we're kind of just starting on that. But the basic stuff is now, in the compiler and it's working, which it kind of hurt my brain to think of how to do it. But once it's in there, it's pretty satisfying that it's in there now.
All right. Well, I'm sure there's a few more questions on your mind. So I have bad news and good news. Bad news is we gotta stop here because we're kind of keeping people from going home. And the good news is there's a number of pieces of good news. T-shirts are to your left as you exit. Christina is going to gladly distribute them to you. Please limit to one per person, or if you ask really nicely, you can get one for your date, spouse, or whatnot. Second, the Hotel Aloft Silicon Valley is actually our informal hub for gathering, where of course we're going to drink only Diet Coke and eat only broccoli. So I'll be there. Walter's going to be there. Everybody who wants to join us would be very happy to continue chatting with you guys. And see you, if not tomorrow, at 8:30. Thank you.